Hello again. So now we are about to start discussing our next topic in geometry, which is circles. So few things about circles. Let's start with very basic concepts, just for us to consolidate, remember some of the terminology that we might be facing whenever we need to solve one of the exercises in these exams. So to start with, let's start just by drawing here the circle. Let's see how my pulse is today. Not that bad. Okay. First and most important concept, this distance from the center to any point on the circle. Remember that this is what we name r being the radius, okay? And then again, the radius being the distance from the center of the circle, okay, to any point on the circle, okay? From the center to any point on the circle there. That will be the radius. That's going to be quite important because you know that the area, the circumference, they both depend on the circle, and hence and some other figures that are based on circle like the sphere, the cylinder. So knowing the radius is going to be super important. So we know that that is the radius, right? Now, if that is the radius, remember what will be the distance. Let's say that is the center, and if you have a distance that goes through the center, right? This is what you call d. That stands for diameter, right? So we can also say that diameter is double the radius and is that distance that goes from one point to another point on the circle going through the center, okay? Now, knowing that that is the diameter, do keep in mind these little guys, because that distance that goes through the center is what you call a diameter, but any distance that goes through the circle, you know, from one point to another point, that might be this one, or might be this guy here, okay? Any other distance, like these ones that I'm drawing in green, this is what you call a chord, okay? So a chord is any distance, or if you draw it, you know, it'll be a segment of a line that goes from one point to another point on the circle, and that's it. So being very specific, the diameter is just a chord, is the longest chord. So it is that segment of line that goes from one point to another point on the circle, going through the center of the same, all right? So keep that in mind. What other important concept? We have a couple of other things. Let's draw again another circle. We know that this will be a radius, right? So from here to here will be one radius, from here to here will be one radius, okay? So whenever you have this kind of figure that is kind of a pizza slice, right? Imagine that this area, okay, this area is what you call a sector, okay? And that part of the circle, you know, like from here to here, there is one segment of the circumference of the blue line. So if I just take this little part here, this is what you call an arc, okay? That is what you call an arc, just for us to know. Remember here as a special note that there are 360 degrees, okay, in a circle. And that arc is, well, one part of the whole circumference that of those 360 degrees. Also, do keep in mind that these 360 degrees in a circle are equivalent in radians. If we talk in radians, that will be equal to 2 pi radians, okay, in a circle. That's also another piece of information that is worth for us to keep in mind. So we know what is the radius, we know what is a chord, we know what is the diameter. Understanding that the diameter is the longest chord in a circle, we know what is a sector, we know what is an arc, all right? There's continuing with this thing of what is a sector and an arc. So let me draw these two guys. So one aspect is that one, when you know when the vertex of the sector is right on the very center, this is O. So if I have that right here, right? I need you to remember, hopefully guys, that the measure of this angle, let's say x degrees, will always be equal to the length or the measure of this arc, okay? To the measure of this arc. So this arc will be equal to pi to x degrees as well, okay? So when the sector has its vertex on the very center of the circle, the angle formed by those two radii, it will be equal to the measure of the arc that it defines. All right, so if this is x, this will be x. Now, there is a special case, and this will be another case here. Let's say that we have a sector, but the vertex is not on the center. Let's say that the vertex is on one point of the circle. So let's say that this right here will be my vertex. And here I define this sector, okay? So whenever we define this sector here, you know that the measure of the angle defined by the sector, let's say that this is y degrees, the relationship with the arc that it describes, so from here to here, right, is that this arc will be double that measure in degrees. So if the sector has its vertex on this circumference, what point on the circle, like this case, the angle that the sector defines is y. Hence, the arc that is defined by that sector will take the measure of double that angle, double that measurement. Okay, I hope that this will be clear enough. And well, just as a quick reminder, you know that the area of the circle is pi r squared, that the circumference, that is the same as the perimeter in a circle, is defined by 2 pi r, or as some other people want to see it, the circumference can be also defined as the diameter times pi, okay, because this 2r will be equal to the diameter. So keep all these guys in mind. These are the basic concepts. Like whenever you're dealing with exercises with circles, you know what are they talking about. Okay, now let's talk about the equation of a circle. So the equation of a circle, the general form, is given by this. Is x minus a squared plus, parentheses, this will be y minus b squared equals to r squared. So from here, what do we know? Whenever we know and we see this equation, we know that is the equation of a circle, and we know that from that equation, the point given by a, b, okay, what I'm doing is minus a and this is minus b, so this is the center, okay, of the circle. So it will be the center of the circle. Now pay attention to that. This is minus a and this is minus b, and here put a and b. So being practical, let's write it down like the center is given by the, we can say what? By the numbers in the parentheses, the parentheses, but with opposite sign, okay? With the opposite sign. We'll have a couple of examples right now for us to make this clear. Additionally, from knowing the center, by seeing the equation of the circle, we also know that this r squared, but where r stands for the radius of the circle. All right? So let's move this into an example, okay? If I have the equation x minus 3 squared plus y minus 2 squared is equal to 9, for example. So remember what we say, the center is given by these numbers, but with the opposite sign. So what I know is that the center is at coordinates 3, right? Here's minus 3, so this is 3. This one in y is minus 2, so it becomes a 2. So this is the center, okay? And remember that this value, the 9, is equivalent to r squared. So from here we know that r squared is equal to 9. Our big conclusion is that the radius of this circle will be equal to 3. This is our big conclusion whenever we analyze that specific equation. All right? Let's go with another example, just to be super clear. If I have here the equation, and maybe I have x plus 4 squared plus y minus 5 squared equals 225. Same analysis. Remember the center. These values, but with the opposite sign. That means that the x-coordinate will be -4 and the y-coordinate will be +5. So this guy will be the center. Now, as this is equal to the radius square, in this specific case, it means that the value of the radius will be 5. Okay? And the last example that I'm going to give you, guys, if you see at any given moment an equation that looks like this, x squared plus y squared equals to, I don't know, 16. So what this equation is saying, it is the equation of a circle, but we don't have x plus anything or y minus anything. So from this one, what we can conclude automatically is that the center of the circle is at 0.00 at the very origin. Okay? And well, from here we can also know that the radius is 4. But if you don't see those numbers, like the parentheses and the number accompanying the x or along with the y, that means that the center of the circle is on the very center. Okay? So this will be the equation of the circles. All right? Common practice, common exercise that you might be given in the exam normally is, or the big tip for you would be to complete. Okay, always what you want to do is whatever you're given, by complete the perfect square. Okay, always. Why? Because whenever you complete the perfect express, you can express it in this form. Okay, what I'm saying here basically is at any given moment you have something like x squared plus 8x, this is equal to, I don't know, to 9. Okay, so this is still not a perfect square. If we want to go back, so we can write the equation in the form x minus a squared. So what we need to do is to complete this guy. And what I mean by completing is, this is x squared plus 8x. Let's delete the space here, so it will be a 9. So remember, what is the perfect square? Is the first term squared plus twice the first term times the second. So that means that this term here represents twice the first term times the second, that we don't know in this case. So 2x times something. We need to figure out what is that something. For this thing to be true, should be 2 times x times 4, right? So that means that 4 will be the second term in my perfect square. And if we complete the perfect square, it says the first term square plus 2 times the first times the second plus the second square. As we know that the second is 4, so this will be 16. Now, remember that if I add it on one side, I must add it on the other side as well. And check out here what will be the next step. When you get to do that, I can rewrite this as being x plus 4 squared. Okay? Equal to, this side will be 25. So this is what I mean when I say that you, in many exercises regarding circles, you need to complete the perfect square. They might give you just this expression. So we want to find what is that second term. Remember that if we solve, check it out, that if we solve this, we get the first term square, that is x squared, plus 2 times the first times the second, so this is 4x times 2 is 8x, plus the second term square, which is 16. That is always what we want to do, because if we are able to rewrite the equation in this form, we will be able to know what is the center of the circle. Okay? Watching the videos and some exercises regarding circles, you will see exactly how do we put this concept into practice. Okay, so hope that this video helps. As always, may you have any sort of questions, email me and I'll try to get back to you as soon as possible.